Okay, let's talk about the Venn diagram. The Venn diagram offers a powerful way to visualize relationship between sets. So let's take for example a universal set U, which contains a set of all people, and a set A, which is a set of uniformed workers, and then a set B, which is a set of army workers. You can see that army workers are people who wear uniform, so they are a subset of uniformed workers. So we can say B is a subset of A because army workers are part of people who wear uniform, or part of workers who wear uniform. The same way, we can say that uniformed workers are part of all workers, or uniformed workers form part of the universal set here. So we can say represent that information as A is a subset of U. We see that B, which is army workers, is a subset of A, which is uniformed workers, and then A is also a subset of U, which is all workers. This information can be simply illustrated on a Venn diagram as this. So we see that a set U, which contains all people, is on the outer side of the illustration. Then in between or within, we see the uniformed workers, that is A. And then within the uniformed workers, we see army workers. This is how the Venn diagram can make a concept look really simple. So this illustration is what all the information we have here is all about. So uniformed workers is a subset of all workers, and then army workers is also a subset of uniformed workers. Another one, take for instance a set, universal set U, which is a set of all students, and then a set X, which is a set of male students, and also the set B, which is a set of male students who play football. Okay, we can see that male workers are a subset of all students, and then the male students who play football is also a subset of male students, and that information is what we find in the Venn diagram here. So again, we see how the Venn diagram simplifies a really bulky information. So that is how powerful the Venn diagram can be. Okay, so we can see that B is a subset of X, which is also a subset of U. Now, when using the Venn diagram, we can talk of certain operations that we use. And the first one is intersection. The first operation we can talk of is the intersection. The intersection refers to members which belongs to the set in question. So if we have two or more several sets, and then we have certain members belonging to all of them, then that is the intersection, and it is denoted by this n-like symbol. So we can have a set of students who are learning French as set Y, and then Z being set of students who are learning English. That information can be represented in the Venn diagram as below. We find the French students here, and then the English learning students here. Then we see some people who are in between both of them. We have Tom and Pat, which illustrate that Tom and Pat studies French. At the same time, they study English. So in this way, you can see that the intersection between French students and English students are Tom and Pat. So Y intersection Z is Tom and Pat. That is how we illustrate the intersection when we are using the Venn diagram. Take for example this. If you have a set A, which are multiples of 3, and then set B, which are multiples of 4, given that they are up to 24, the A ends at 24 and then the B2 ends at 24, what will be the intersection between A and B? Look here, we find that 1 is here, 1 is also here, so that forms part of the intersection. We can also see that there is 12 here and then 12 there, so that is also part of the intersection. Then lastly, we find 24 and then 24, so that also forms part of the intersection. So we can illustrate this information in the Venn diagram as below. We can see that all the information, all the members that belongs to only A are here, and all the information that belongs to only B2 are here. Then the intersection points of them, we find the members which belongs to both of them there. So that is how we use the intersection. Okay, let's see about this one too. We see that we have Y, which is a set of the vowel alphabet A, E, I, O, U, and then Z, which has these elements B, C, D, and G. What is the intersection between Y and Z, and how would you represent it? You find that these are all vowels, but then there is no vowel sound here. So as it turns out, there is no intersection between Y and then Z. So the intersection of Y and Z is a null set or an empty set, like we learned earlier. And so when you want to draw a Venn diagram for that, that is how it can be represented. There is no intersection between them. Next, we'll talk about the union set.